sponsored by NSF-ATE. Karen, welcome, and thank you for bringing your team and your expertise in manufacturing now for this combined effort on AI in manufacturing.
Oh, thank you, Antonio. It's an absolute pleasure to be here and work with the consortium. We just completed a summit at FANUC, which is a worldwide producer of robotics, and AI was continuously in the presentations. So we talked a lot about the consortium and this partnership, and certainly also working with Microsoft. So I'm really excited about next steps. Marco Tavener and Wendy Robichaux is also here from my team. They're like Cynthia's times two. But again, we look forward to the presentation and then where we go from here. So thank you.
Thank you, Karen. And so for everyone joining, I see we have 77 participants, super excited. I'm glad to see this engagement on this topic. So we're gonna go now, we're gonna pass it to Black Dog Black Cat. They are a Microsoft training provider that is just prepared this nice presentation about what's happening on AI manufacturing. They're gonna talk about use cases. You're gonna see some exciting products that Microsoft have developed and how companies are using those products specifically about AI in manufacturing. You're going to see very different examples and projects that are, again, super exciting. Just tune in. We're not necessarily, you can send questions to the panelists. We're not opening for conversation, at least not for now. We want to stay focused on the presentation itself. But at the end of the presentation, then we're going to talk about next steps. And we have, some next steps to continue this conversation at the end. So stay tuned in until the end. And with that, Bear, it's a pleasure to pass it to you. And Alexandra, you take it from here.
Sweet. Thank you, Antonio. Hi, everyone. Welcome again. Uh, we're going to be using the Mentimeter a couple times during today's presentation, so just make sure to keep it open. But again, my name is Bear Ulrich, and I'm being joined by my colleague Alex Arnold and Liz Budowicz from Black Dog Black Cat. And we're really excited to show you guys how to explore artificial intelligence in reshaping manufacturing and how we, as educators, can prepare our students for this new technologies and futures. But before we get too far into this, we just want to make sure that you all know that this broadcast is being recorded. And if you do not consent to being part of the recorded session, to please disconnect your line now. This recording will be made available after the event. And if you choose to participate in this Microsoft team or in this Zoom event, your name and email address and or title may be viewable by other participants. So here is what we're going to be covering today. We have our welcome and objectives. We have the importance of AI in the manufacturing. We're going to talk a little bit about what AI even is. And then we'll go through a lot of use cases or successful case studies of AI in manufacturing settings. And then also, like Antonia said, then we'll be going over resources and next steps. So this webinar is a survey of ways that AI is used in manufacturing in order to help community college faculty get started in thinking about how we may want to include AI in our curriculums. And at the end of the webinar, we will share links with next steps to get involved with other faculty working to build this material into our coursework. So here's another Menti. It's the same code, and it should have updated on your phone. That's okay. If this one doesn't work, that's okay. So we'll just go ahead and go into the importance of AI in manufacturing. So artificial intelligence is driving major shifts across the manufacturing landscape. And at its core, AI supports innovation from helping manufacturers design and launch new products all the way to helping with production logistics. And so AI is helping to unlock additional value or help manufacturers get more value with their time by improving efficiency, by reducing waste, and enabling smarter decision making across the entire value chain. It also helps to strengthen our supply chain resilience by anticipating disruptions and optimizing operations in real time. And then in the literal factories themselves, AI enables intelligent systems that learn and adapt, which leads to more responsive, data driven environments that ideally are able to produce more as well as are safer for workers. And then beyond the shop floor, it helps to modernize how manufacturers interact with their customers so that experiences can be more personalized and service can generally be more improved. As educators, our role is to be able to help students explore how these tools are not just technological upgrades, but that they're part of a broader transformation in how manufacturing, the entire manufacturing industry, works and evolves. And so AI, whether we want it to or not, is redefining manufacturing from intelligent factories to product innovation. We as faculty can help students connect classroom skills to the future needs of our workforce. And so AI is generating real excitement in manufacturing, and it's more so than in other sectors. And so this study is one that found that leaders view AI as essential to the intelligent, hyper automated factory, and that most manufacturers are actively exploring AI, with over 60% of them already in research or pilot phases, and then about 35% already using AI in their operations. And the common goals of all these manufacturers with applying AI is to improve speed, to further innovation, to help increase their security, and then also reducing waste and carbon emissions by making their operations more efficient. However, scaling AI is not a simple task. Manufacturers are also facing challenges with talent, with data quality, and with infrastructure, especially in engineering and operations. And so we as educators get to play this vital role in preparing students to be able to face these challenges in these environments by emphasizing design and systems thinking, data literacy, and then also ethical use of AI tools. In a recent global survey of manufacturing leaders, one challenge that stood out above all the other ones is a shortage of AI skilled talent. So, a shortage of people with the skills required in order to use and implement AI tools. And so, while the potential benefits of artificial intelligence, such as the improved productivity, smarter decision making, and more resilient supply chains, are widely recognized, many organizations struggle to turn these possibilities into reality. And the reason is because they lack workers who understand how to apply AI tools, how to analyze data effectively, and how to collaborate with these emerging technologies on like the shop floor. And this gap in workforce readiness is the bottleneck in slowing down progress and limiting the impact of AI across this industry. For educators and training programs, it's our call to action. We need to be preparing our students to not just be able to know how to operate machinery, but to be able to lead the next wave of intelligent manufacturing. And so teaching AI concepts, practical applications, and data literacy can help us close this gap and equip learners to drive innovation where it is needed most. And so this figure on the slide just shows not just a need for AI skills in engineering, design, and research and development, but also for factory production. And so we're going to take a moment and take a step back and make sure that we are all on the same page on what artificial intelligence even is. And generally, it's this broad field that includes machine learning, computer vision, natural language processing, and more. And these technologies are already embedded in our daily lives, from voice assistants to smart devices. And so you've probably already encountered AI in your daily life through your email spam filters, credit card fraud detection, or your different recommendation systems on whenever you're doing online shopping or like trying to access a service for streaming videos. Um, but now fast forward to today, and now we're seeing AI in our facial recognition to unlock our phones. We're seeing self-driving Waymo cars, and then now there's this abundance of generative AI tools that are widely accessible, like ChatGPT, like Claude, and like Microsoft Copilot. And all of these examples are just showing us how AI has moved from hyper niche applications to things that are everyday tools. And now it's entering into the manufacturing world in new and powerful ways. But what makes generative AI different from other AI tools? Or just talking further about what AI is. And so at its core, artificial intelligence is a technology that is able to learn using data and perform tasks that we ask it to. Sometimes tasks that are traditionally have required human intelligence. And so this slide gives us a snapshot of the major categories of AI technologies. We have generative AI, which is what powers tools like Microsoft Copilot or image generators. It is able to create new content, new text, new images, and even music based on patterns it has learned in existing data. There are also agents and automation, which refer to systems that can carry out tasks on their own, like scheduling meetings, managing inventory. These are especially powerful in streamlining repetitive or rule based processes. There's also natural language technologies that allow machines to understand and respond to human language. Excuse me. This includes things like voice assistants, translation tools, and chatbots. Then there's computer vision, so like how computers are able to see uh, and interpret visual data. So identifying objects in photos or helping self-driving cars to be able to navigate the roads and traffic and pedestrians and cyclists. There's also information extraction, which is about pulling meaningful insights from large volumes of data, such as summarizing different documents or identifying trends in customer feedback. And all of these tools are powered by machine learning, which simply means that a system is able to learn to predict an output based on data that we input without being explicitly programmed for every single scenario that we might need it for. And together, all these technologies form the backbone of modern artificial intelligence systems, and they're transforming how we work, how we learn, and how we interact with the world. Microsoft's approach to responsible AI is grounded in 6 core principles. So we have fairness, we have reliability and safety, we have privacy and security, we have inclusiveness, transparency, and accountability. And these principles guide how AI systems are designed, developed, and deployed to ensure that they are ethical, trustworthy, and beneficial to society. And so, this framework that Microsoft promotes emphasizes human oversight, clear communication of AI's capabilities, and inclusive design that empowers people of all backgrounds. And we encourage you to learn more about these principles using Microsoft's Learn webpage on responsible AI principles and their approach. And if you'd like to think of more about how you could apply these principles into the classroom, we also recommend their training on Microsoft Learn on applying these responsible AI principles in learning environments. You can also make sure to check with your institution and your IT department for your specific AI use policies. And so now we're going to explore how AI is applied in manufacturing, and we'll take a look at some real world examples across several domains. And in each case study, from Volvo to Bridgestone to Sandvik, we're showing how AI is already transforming operations like right now. Or is this one going to work? All right. So we'll have to figure that out for next time, but that's okay. But Alex, do you want to kick us off with quality control with computer vision?
Yeah. And so, Bear gave us a really thoughtful introduction to AI and how it's kind of revolutionizing the manufacturing sector. And so now we'll start to get into some case studies and some use cases for applications. And so one of the most impactful applications that we've seen so far is quality control. And so we can do this with computer vision. And this is really revolutionizing how manufacturers are maintaining their standards and how manufacturers are operating really efficiently. And so they are automating these inspections that are going on in assembly lines. And by doing this with AI, they're able to detect defects in real time. They are able to increase accuracy, the packaging accuracy, and it's reducing reliance on manual checks. So this is really just a process that streamlines efficiency. And so we can use and analyze this data that the machine collects and collect also kind of hindcast it back to the design process. And by gathering all these data and insights, manufacturers can use this to refine the quality of their products and streamline that as well. And so overall, using computer vision for quality control really increases operational efficiency and in the long term can hopefully lower production waste. And so this kind of transitioning from product quality on the surface to going behind the scenes in making sure that things that are manufacturing, the machinery itself is running smoothly. Another thing that AI can help with is predictive maintenance. And so you can take these instruments and put some sensors on there and use artificial intelligence and data science to monitor equipment health in real time. And I'll show an example of this in just a second. But essentially what they can do is look at all these different variables and predict when failures can occur. And if they have insight on when failures can occur, they can make sure they're taking care of it. So increasing the life of machinery and the assets. They could minimize downtime. So making sure that, we're fixing a problem before it becomes a bigger one and you end up having to delay some things. And it can also optimize the resource use. And so overall, implementing predictive maintenance really supports a safer and more efficient production line. And so we'll go to the next slide, which will show an example of this in practice. And so we're probably familiar with Bridgestone, Bridgestone tires, but this is essentially a case study where Bridgestone was facing some difficulties in slowdowns that were impacting its productivity. And so they had disconnected information and operational technology systems. And so it was really difficult for them to diagnose equipment issues. And to address this, they utilized Microsoft Fabric, which is part of the Microsoft Cloud for manufacturing. And putting all this information and data together, they were able to consolidate machine data, and it gave them more insights on downtimes and loss metrics. And so overall, implementing the system really gave folks a better idea of what is happening on the factory floor. And in addition to kind of doing that predictive maintenance, they also have implemented generative AI systems. So they had a conversational AI agent that was built on Microsoft Azure. And this allowed workers to essentially use natural language to chat with the AI agent to do troubleshooting. And so that also increased efficiency as well. And so both of these things together really were helpful for Bridgestone because it reduced the amount of downtime that they had and also increased productivity of folks that were employed. And overall, both of those things are improving operational efficiency across their plants. Okay, so this is an example. This is a tutorial I will link in the chat for you to take a peek at if you'd like. There we go. But essentially, this is an example of a fault detection model. And so the goal of this is to predict when a machine might fail before the machine actually fails. So the link has the technical demo that you can do, but I'm just going to kind of walk you through it and show how you could use this within a classroom. And so the first step is going to be to collect the data. So from a different piece of machinery, you can have sensors that detect temperature, it can detect speed, pressure, whatever variables you're interested in or that are important for that machine. You can get a sensor to detect those. From that raw data, we then need to prepare it. So we'll clean and organize that data in data preparation. And then finally, we'll take that data and we will implement it in an AI model. And so AI will start to detect patterns within that data that signals when something might be potentially failing. And so the plot on the right is showing the example that's used in this study. And it's showing the relationship between tool wear and torque. And if we look at the plot, the blue would indicate a successful, like non-failure, when the red indicates failure. And we can see that there's these kind of natural breaks within the graph. And so these would be stress points that could be identified from the data to say, you know, when we hit a certain amount of tool wear, things start to get a little messy. You know, we're starting to see more failures. So it can start to inform folks about the machines that they're using. And so this tutorial could really spark a conversation about how using AI in the real world in manufacturing can reshape the future of work. It kind of extends AI beyond theory and shows them a direct application in an industry that they might work in.
And so now that we've explored computer vision, we've explored its application in predictive maintenance. Um, a step further of that are digital twins. And so imagine having a real-time virtual replica of that equipment that Alex was just talking about. One that's not only tracking performance, but it's also able to simulate future scenarios. And that's where these digital twins are able to come in. They are built on the same data-driven foundations that predictive maintenance are, but they offer an even broader and more dynamic view of entire systems. And so digital twins are probably one of the most exciting tools in modern manufacturing. And so you can think of them as like ways that there's like there are digital they're digital twins. Sorry, I was trying to come up with something clever. But you can make these digital twins for things like for specific machines that we have, entire production lines, or even entire facilities. And these digital twins are able to update in real time using data from those sensors that Alex was talking about and connected systems. And so digital twins can simulate everything from a single machine to a full production line. They can integrate IoT and business systems for automated control and data flow. They can provide real-time insights to monitor performance and be able to detect issues. They are able to visualize operations in 3D, layered with business logic, so you can start bringing in other types of insights that you'd like. And then they're also able to analyze historical data due to forecast trends, and this will help you improve workflows. So enabling you to be able to look at how things have gone in the past in order to better understand how you should move forward more efficiently. And so in short, digital twins help manufacturers to see, to test, and to optimize their operations before making these actual changes in the real world. You can think of these as like being able to prototype things, being able to just like play test things, be able to limit test things before you actually try to implement those scenarios in real life and cost real money. So from a teaching perspective, digital twins offer a great way to be able to connect our data science and engineering and systems thinking. They're also powerful examples of how AI and cloud computing are able to come together to solve real world problems. And so to bring this concept to life, let's take a quick look at this short video that shows how digital twins are being used in mixed reality and metaverse applications. And it's a great example of how these technologies are evolving and how our students might be able to one day work with them. And Alex, you can tell me if the audio on the video is working or not. Oh my gosh. 1 second. We will do a little workaround. So let me open up this video. Okay, and we'll start sharing again with sound.
Imagine our world today. People, vehicles, businesses, buildings, hospitals, factories, entire cities, and the billions of devices that connect us to this world and to each other. This is the physical world. But what if we can replicate that physical world into its digital twin? A digital twin that is bound to the physical world in real time, that we can experience in mixed reality, that we can collaborate with, that we can run simulations on and find what is important to us, that we can apply AI to learn, predict, and act, to save time and money, to reduce carbon, to preserve natural resources, to improve safety, to bring us all closer. This is already happening today. Across the world, organizations are taking advantage of this new wave of innovation that trends to an interconnectedness that enables the metaverse. Everything modeled in the metaverse mirrors the status of its physical twin, including the interactions and relations between everything else. By applying the power of the cloud, we eliminate boundaries of what this can do. The potential is limitless. We can now track and analyze data from connected environments to identify patterns, trends, and anomalies. We can now simulate any possibility, evaluate outcomes, determine the impact of any change or condition. We can now harness AI to perceive the physical world, to improve and automate tasks, to give superpowers to your frontline workers. We can now give everyone in your organization the power to build apps and workflows, to collaborate with each other in this virtual space, to share and receive expertise at the right time with the right context in front of you, to move through the physical world and get relevant information about its digital counterpart when and where you need, using mixed reality. The Microsoft Cloud brings these capabilities together with the limitless computing power of the cloud and intelligent devices at the edge, and creates this framework for building immersive and impactful digital twin, mixed reality, and metaverse solutions.
Pretty cool. And the music always is fun. All right, so I will switch back to sharing our PowerPoint. I lost Zoom. I lost my Zoom bar. Hello? Oh, there we go.
So while Bear's working on getting those up, we're going to kind of transition from the digital twins, which is really meant to optimize the physical systems and processes, to some more behind the scenes kind of work. Oh, I think you're on the wrong screen. But
I was.
no worries. So next we'll look at intelligent data processing or document processing. So sorry. And so that will look at how manufacturers are handling a lot of their documentation and data. And there are a lot of really cool case studies. We'll get into some of those afterwards, ranging from processing invoices to different compliance reports. Essentially, in manufacturing, there's a lot of paperwork, and we can start streamlining that by using AI. And so we can take AI and we can take all those documents and we can begin to extract and process information that we have in there. And that can range from scanned forms that it can extract data from PDFs that you send, things in emails, reports, etc. And so we can use this intelligent document processing, or IDP, to capture data in structured and unstructured formats. And overall, what this does is it reduces the amount of time you have to spend in manual input, but it also helps increase accuracy. I know I am prone to typos, and so is everyone. It happens to the best of us. But it really helps to streamline operations in that way. And so, as I said, this can support, invoicing, delivery tracking, compliance, and using an intelligent document processing and teaching about it can offer students kind of a practical view of how AI can enhance efficiency in a really large scale in manufacturing and for, I guess, digital workflows in general. And so we'll go to our first case study next, which is Volvo. And so this is kind of IDP in a real world manufacturing setting. And so Volvo, you might know them by cars, but they also manufacture trucks, buses, and industrial equipment. And they were using AI to solve an operational challenge for them, which was invoicing and claims processing. And so the former way that Volvo used to do this was exceptionally time consuming and error prone, especially with manual input, because employees were manually taking all of that data from a bunch of documents, images, stamps, multilingual content, and having to do that all by hand. And what this caused is a really big slowdown in their workflow and a bottleneck in terms of their reporting. And so to address this problem, Volvo worked with Microsoft Azure to develop an AI-powered solution. And this also used Microsoft's AI document intelligence. And they trained this model, they trained their system to extract data from many different visual formats and translate the documents they have into several languages. And so this made it a lot easier on their employees to access and process information both quickly and accurately. And so they had this pilot program for 6 weeks and then had it in production for four months. And then they finally deployed it to all of their facilities. And the impact overall, they estimate that over 10,000 manual hours was saved. Operational efficiency was greatly increased, and there was a lot more support for its workforce, given that, they're no longer spending their time manually extracting all of these things. So this is a great use case of how intelligent data processing can give folks more bandwidth to do other things. All right, and so next we can get to one more case study about this. This was Textron Aviation. And so they had a similar challenge where we're using intelligent data or document processing, but they're applying it to aircraft maintenance. And so Textron was a manufacturer. They're known for iconic aircraft like the Cessna. And they had a lot of documentation for their planes. So overall, there were 60,000 pages of information, and they're going over 50 different types of planes. So there's a lot of information that folks had. And you can imagine if they needed to search manually for something, it was a really time-consuming process. It was super inefficient. And that's not very helpful, especially when you're in a high-pressure service environment. And so they partnered up with Microsoft to develop what they call TAMI. And so TAMI stands for Textron Aviation Maintenance Intelligence. And it is an AI-powered assistant built with Azure and Cloud for Manufacturing that essentially helps technicians to do their job more efficiently. And so they consolidated all of that information. And now technicians can work with this AI-powered assistant to access maintenance instructions just using natural language, like we would talk to Copilot. And the impact of that is we went from troubleshooting time being 20 minutes to being roughly 1 to 2 minutes. So that's a 10 to 20 times increase, like decrease in time consumption, which is amazing. And also, given that this is a global company, the capacity to be multilingual and support these multilingual questions is really important. So that we're able to streamline that as well. And so this really transformed the productivity of technicians and helped them keep their aircraft more operational, decreasing downtime. And implementing a generative AI solution in this case with IDP was really, really helpful in kind of streamlining the operations in a really complex manufacturing environment.
And so the next thing we wanted to talk about as an application of machine learning or artificial intelligence to manufacturing is generative design and simulation. And so this next frontier is where AI and high performance computing are able to come together in order to like help us accelerate innovation and start creating new things and new technologies in order to make our lives better and make new products. And so generative design and simulation technologies enable manufacturers to test product concepts virtually. So similar in a way to digital twins, but now we're like more on the prototyping side of things before committing to physical prototypes. And so these tools use high performance computing to model real world simulations or real world conditions, such as stress, such as heat and motion. So any of the things that we were getting sensors for in order to monitor for our actual instruments, we can also just simulate those conditions as well in our prototyping. And then we can refine our prototype designs accordingly. And so then by potentially identifying risks or potential risks early on and doing this digitally also helps us to iterate rapidly instead of having to like design a prototype, send it off to get it produced, and then iterate that way. This we can do digitally, online, tons of different conditions, tons of different materials, all from the power of our computers, which is incredible. And so this helps us to rapidly iterate. It helps us to save time, reduce costs, improve product reliability because we can test more and more conditions. And so for us as educators, this represents a teaching opportunity that we can introduce to our students to digital workflows for what drives smarter engineering and accelerates innovation across the production lifestyle. And so one case study of this was done by Harting. And so they used these principles to dramatically improve their product configuration and prototyping. And so Harting is a global leader in industrial connectors. But they, back a couple of years ago, they faced a major challenge, which was helping customers choose the right product from their catalog of over 27,000 options. And so this process of like trying to get customers to choose products was slow. It was highly technical and often required expert support, of course, because how are you supposed to make the best decision for yourself out of 27,000 options? And so the initial benchmark point was that it would take up to 20 minutes just to configure a single product. But to solve this, Harting developed this Han configurator, which was this AI-powered assistant tool built using Microsoft Azure OpenAI service. And this solution allowed users to describe their needs in plain language, and then the AI tool helped translate those into precise technical specifications, which helped to bridge the gap between the customer's intent and what they're describing that they want and the engineering complexity of all these different 27,000 options that are in this catalog. This assistant also helped to support the engineers by refining their 2D layouts, verifying design details, generating 3D models of these options, and then even performing basic thermal simulations. And so this level of interoperability means that what used to take weeks, a process that used to take weeks, like creating custom prototype concepts, could now be done in minutes. That is like magnitudes upon magnitudes of less time. And so then the results speak for themselves. So configuration time has been reduced by 95%, and Harding has saved over, again, 10,000 manual hours. And this case is a powerful example of how AI can democratize design, accelerate innovation, and make these advanced engineering tools accessible to both the experts and the customers. This one's all you, Alex.
Perfect. So in addition to all we've mentioned so far, AI can really help with manufacturers and how they're managing their supply chains and their inventory. And so we can take all the data we're getting, we can take data from production system, from suppliers, what the market trends are to forecast things. And we can use all of that to essentially enable smarter decision making and more informed model-driven decision making. And we can have enhanced insights from using these AI tools to forecast demand with greater accuracy. If you know the market trends, you can anticipate exactly how much you'll need. You can do inventory planning. And so we can look at how this is done in an AI environment, and students can begin to think about, how AI is kind of making this a more efficient process. So a lot of folks have been using intelligent fulfillment systems and warehouse operations, and that really allows for a streamlining of logistics and improvement in customer satisfaction because you're getting a faster and more reliable, hopefully, delivery. It can also contribute positively to the supply chain by getting us a little win in sustainability. And so this can help, we can be more sustainable by reducing the amount of excess inventory we have and trying to streamline and minimize the environmental impact. And so we can align what we have in the supply chain with broader environmental goals of the company as well. And so what does this look like in practice? This is an example from Dow, a material science company, and they had their major challenge was that they were verifying a lot of freight invoices, over 4,000 shipments a day, which is a crazy large number. But before implementing an AI solution, this was obviously a very slow and labor-intensive process that missed some hidden overcharges in the process as well. And so they developed this AI through Microsoft Copilot, so generative AI system, and developed some autonomous agents that they could implement within their business to analyze shipping data in real time, to flag any discrepancies that came up in billing so they weren't overcharged, and to help them with the auditing process. And we see that efficiency exponentially increased. What would take days or weeks happened in minutes. And overall, this is saving folks a lot of time at the company. It's reducing costs. And, if there are overcharges, it's a substantial amount of savings as well. But after Dow implemented this AI Copilot, they found a lot more ways that they could begin to integrate AI within their workflows. So they identified 100 other use cases in their company that they could streamline using artificial intelligence. And so this really shows how you can take targeted AI applications and really transform a company to drive efficiency, look at uncovered value, and support smarter decision making.
And so now we're going to switch topics a bit because we've seen how AI can streamline logistics and maintenance, but it's also helping manufacturers to work smarter and more sustainably, which is great given the current state of our climate. So by analyzing real-time data from our smart sensors and our equipment, AI is able to detect inefficiencies, predict maintenance needs, and automate systems like lighting, like HVAC, and machinery in order to reduce energy waste or waste of other types of fuels. It also helps us to optimize our production schedules to avoid peak energy demand and can even simulate energy saving strategies before they're rolled out through like the digital twins, like the prototyping that we talked about earlier. And so these tools don't just cut costs, but they also support our sustainability goals by reducing emissions and promoting cross-team collaboration for continuous improvement. And so for students, this is a powerful example of how data analysis connects directly to environmental impact, and it shows how AI can improve everyday operations while advancing broader sustainability efforts in manufacturing. We also have this example of as AI continues to reshape manufacturing, one of the most visible changes on the shop floor is the rise of collaborative robots, or these have a cute name called cobots. And unlike traditional industry robots, AI-powered cobots are designed to work safely alongside humans. And so they use intelligent sensing to understand their physical surroundings. They are able to adapt to changing tasks and environments and even make real-time decisions based on the information that they're getting from their sensors and the data that they're getting fed through production. And some of these cobots are even able to use machine vision or computer vision to detect defects and guide precision work, which were tasks that once took or required highly specialized subject matter experts like that were human. But because now that they learn from experience, their performance continues to improve and continually iterate over time. So they know what they're doing. For students and faculty, cobots now offer this like hands-on example of how AI is able to enhance flexibility, safety, and efficiency on our machine floors because they represent the shift from rigid automation to intelligent collaboration with the machines we're working with and designing, where machines support human workers rather than replacing them and making manufacturing smarter and more responsive. And so we have a real life example of this from KUKA, which is a global robotics leader. And they faced this major challenge of how to figure out how to manage the performance and maintenance of thousands of robots operating around the world while ensuring that they could safely work alongside humans in these different dynamic like workshop environments. And so the solution they ended up coming up with was working on a software platform that they built on Microsoft Azure's IoT. And by integrating their cobots with Azure, KUKA was able to integrate or enable real-time monitoring, predictive maintenance, and adaptive task execution, which means that their cobots could now sense their environments. They could adjust to the changing tasks that they were being needed to do. And then they can even anticipate when they need maintenance before any problems occurred. And so the impact that this change up that they implemented has is that the human robot collaborations are safer thank you to the intelligent sensing. They get real-time insights on the cobot performance and health, so they know when things are about to go awry or like when things need to be taken, things need to be checked out. The unplanned downtime amount has dramatically decreased thanks to the predictive maintenance. And now they've also been able to unlock flexible automation that supports the demands of smart factories. And so these are examples of how AI and cloud technologies are not just theoretical concepts, but they're actively transforming the manufacturing landscape right now. All right. And
Perfect.
so, yeah, go for it.
Oh, all right. So now we're just going to share some resources and next steps. So I'm going to put in the chat right here. It's just a brief knowledge assessment. You can access it using the link in the chat or on your phone using the QR code. But we'll give folks 2 minutes-ish. It's fairly short to complete that, and then we'll come back for some next steps afterwards. We've got about a minute left. All right. We'll move on, but we'll include this link for you to continue to fill it out if you haven't had enough time. But we can go to the next slide. So as we're beginning to wrap up, we're going to leave you with a few resources that will help you dive deeper in AI and manufacturing. These range from some of the case studies that we discussed today to curriculum tools and hands-on platforms you can start to explore for yourself and for your students. And a lot of these are great examples. They're great starting points for understanding how AI is being applied in real-world manufacturing and how you can bring those within your teaching. And so, yeah, we'll be sharing the slides with all these links, but it's really been a pleasure to be with you this morning, or if you're on the East Coast, I guess this afternoon. It's been great to share this space with you. And then I will hand it over to Antonio, who's going to elaborate on some next steps. So over to you, Antonio.
Thank you, Alex, and I bring Karen back with me here because we wanted to have this as the first webinar focused on the topic of AI manufacturing, but the Next Gen National Center focused especially on manufacturing is having a full transition and focus on artificial intelligence. And with the National Applied AI Consortium, we're all about artificial intelligence and applying that artificial intelligence. So we're combining forces to really make this bigger collaboration for any community college in the nations that want to evolve into AI in manufacturing, whatever avenue of manufacturing. We want to create this community of practice where we can start defining and finding the pathway for resources, courses that are being created already, or companies that have opportunities to engage in AI manufacturing from a community college perspective. So we wanted to invite all in this call to join us on the first community of practice gathering related to AI manufacturing. It's going to be taking place just a couple of weeks from now. And really, the idea is let's get together everyone in the community college environment that wants to work on AI manufacturing, faculty, administrators, even employers that might be interested in this topic. And we will bring what we have got from Microsoft. Today we had a great presentation about the resources, but beyond that, all the opportunities to engage in AI manufacturing. Karen?
You said it very well. So we really, this is a community effort across the United States. Both our national center and the AI consortium, we're national, so we want to hear from all of you and learn from what you're doing as well as what your challenges are, because I think collectively we can make a big difference. So, and thank you for this presentation today, Cynthia, for all your hard work putting it together, and Microsoft and Antonio. I think if this is an example of next steps, we are well on our way. Thank you.
So QR code, you can register right now. If you are not able to attend, are we recording? Yes. All our sessions are recorded and then they are available on our website for anyone that wants to watch a recording. But at the end, I think it's relevant, definitely the registration is just to start building, even if you cannot make it, that you are going to be part of a group that wants to work on this, that want to create resources, that want to share resources more than anything. And we already have a repository of content available. We want to start expanding now with AI manufacturing content. And we know about some colleges that already have courses or even programs. That's what we want, to elevate the opportunity for everyone and really to be able to support any community college that wants to do AI manufacturing. So with that, thank you all. Cynthia, any final comments, any logistical detail that we missed?
Nope, that was perfect. So I will go ahead and send communication after this to everyone who attended, and I'll put the link of where you'll be able to find the recording, as well as I'll also send this so you all have it.
Thank you. And with that, just a big thank you to the Black Dog Black Cat team, Bear, Alex. Thank you very much. We appreciate your support. And of course, to Microsoft for sponsoring this session and the future sessions that we will have about applied AI. Thank you all.
Yeah, thank you. Have a great Friday. Bye-bye.
Bye.
Thank you. Have a
Thank you,
great Friday,
everyone.
y'all.